Okay, hey again everyone. So we just left off talking about the life cycle of data science. And if you remember, step 3 of that life cycle was called model. But I left that pretty ambiguous. What on earth does that mean? So in general, what we're trying to do is, like I said before, create some model that approximates the natural connection between independent and dependent variables. There's a bunch of names for this. If you're a mathy person, you might call this statistical inference. Statistical inference. I apologize in advance. My handwriting is terrible, and so is my spelling. You're going to have to bear with me. So if you're not as quite of a mathy person and you're more of a computer science person, you might call this machine learning. For the remainder of this course, I'm probably going to be using this term. I think it's the more open-ended term, and it applies a little bit better to the kind of new school way that we're going to be doing things. I called out a paper by Leo Bremen. I hope you definitely read it. And I hope that you'll start to understand why I'm hoping that we're earning this second definition of modeling. Okay, so I want to talk just a little bit about what this is. It's kind of weird when you start off thinking about this. Machine learning. Well, how on earth can a machine learn? How does that work? Well, it's actually not nearly as hard as it sounds, like a lot of things. What we're going to ask the computer to do is to learn from past experience. And more specifically, what we're going to say is, okay, computer, here's a whole bunch of historical data, history. And inside of that historical data, there's going to be lots of individual observations, and we'll talk about this, what that means more in a second. And what we're going to do is ask the computer to look at this history and come up with some general rule. So let me give you just a little bit more intuition on this. This is a story that I always like to tell whenever I'm talking machine learning. Not too long ago, about 5 or 6 years, I decided that I was going to start running. And since I've started running, I've done 4 marathons now. A marathon, if you're not familiar with it, it's a 26.2-mile run. And I've done 4 of these. And in my experience, what I've found is that every time I've done this, I've found this process of running a marathon to be painful. It hurts. And so if you were to ask me if I had some general rule about running marathons, I would tell you that my general marathoning rule is that marathons are equal to pain. They hurt every time. So there we go. It's just a little bit of a silly story, but it shows you the idea. I use 4 examples that have happened in the past, and I come up with some general rule. That's exactly what we're going to be doing with machine learning as well. So we'll get more into that in just a second. But first I want to talk about some of the different types of machine learning. In general, there's 2 categories. Category 1 is supervised machine learning. Category 2 is unsupervised. Now, What I'm going to do is I'm going to talk about supervised first and explain that one, and then I'll come back and talk about unsupervised machine learning. But for now, it's good enough to know that there's two types. So, supervised machine learning. Guess what? Inside of supervised machine learning, there's another two types. Type A is going to be regression. And type B is going to be classification. All right. So, what's the difference? What are these things? In supervised machine learning, what we're going to do is we're going to use some labeled data that had happened in the past, and we're going to use that labeled data to predict some other value, or just predict some dependent value based on the independent variables inside of the data. Okay, I know that's I just skipped over a whole bunch of stuff. Bear with me. This will make sense in a second. So let's say that we have, let's talk about regression first. So in regression, what we're going to do, or what we care to do, is predict a value based on the independent variables that make up the historical data. So let's say we have a historical data set, and this historical data set will be house prices. And inside of the data set, we're going to have three bits of information about each house that was sold recently. It will have the number of bedrooms, the number of bathrooms, and the price. So let's say one house that was recently sold had 3 bedrooms, 2 bathrooms, and it sold for $200,000. And then another house that was recently sold had 4 bedrooms and 3 bathrooms, and it sold for $250,000. And then there was another house, it had 2 bedrooms and 2 bathrooms, and went for $150,000, and so on. So what we can do is we can show the computer all of these historical property transactions, or housing transactions, house sales. And what the computer will do with a regression problem is the computer will learn from these and be able to predict house price based on the independent variables, bedrooms and baths. So specifically, what we use regression for is to predict a value. Using labeled data. All right. So let's talk about classification now and how that differs from regression. Classification is slightly different, but it's very, very similar. In classification, what we're going to do is we're going to predict a class. Given labeled data. Now what's a class? Well, think of it as a category, but let's say instead of house pricing and bathrooms and bedrooms, now instead we have a medical test where we have the results of a blood test and does the person have cancer or not? And for each patient, we would have the result, and then do they have cancer? Obviously, that's a very simple one, but the point is this. What we would care to do is predict cancer or not cancer, two different classes, given some independent variables. Very similar to regression. The difference is here we're predicting a value, and here we're predicting a class. All right. So now let's move back to unsupervised machine learning. All right, unsupervised machine learning. So you're probably able to guess what the difference is or what unsupervised machine learning is at this point. In all of the cases of supervised machine learning, our data had labels. We had historically knew that the cancer group had or some group of people belonged to the cancer group, some group of people did not belong to the cancer group. Or we knew that in the case of the house prices, we knew the price for each house. But a lot of times in real world, our data doesn't have labels. And so then what do? Well, we have two different machine learning algorithms that we can use in unsupervised machine learning. Actually, there's more. There's two that we're going to talk about in this class. The first one is going to be clustering. And the second that I'm going to talk about is a recommender. All right, so let me go into how clustering works. This is a fun and very useful model. So what you can do with clustering is you have some data set, and it has all kinds of independent variables, but nothing dependent, or at least nothing obviously dependent. There's no value that you're trying to predict. This happens a lot. And so usually the goals of clustering are to find groups or to find outliers. We'll talk about both of those. So what happens with clustering is I will give the computer all of these observations, and what the computer's goal is going to be is to take all of this data, all of these observations, and separate them into buckets such that each bucket is as different from each other as possible, but such that the data inside of each bucket is as similar to the other data inside that bucket as possible. All right, back up. What does that really mean? What I'm saying is we're going to find groups, or we're going to find things that are similar to each other, and the computer is going to put those together into clusters. So just for example, let's say in our data we might have all kinds of different variables that we have collected about our customers. Maybe some of them like to read specific magazines, or maybe they like to drive cars, or they have another hobby. So what the computer would do is it would take all of our customers and it would try to, imagine if there were only two variables, it would try to plot the data points of those customers around the centers of the group, and we call these centroids, so that we can discover clusters in our data. And then what we can do is we can go back into these clusters and we can say, all right, what is it about this cluster that makes all of these users kind of the same? Well, maybe it's their hobby, maybe it's their age, maybe it's some other thing that we know about them. But regardless, it's usually some variety of the things that we know about each customer that's going to pull them together into this common group. There's another thing that's really powerful here, and it's not incredibly obvious in the surface, but what we can do is we can find maybe there's a couple of points, maybe there's hundreds of points here. but maybe there's only a few points in a cluster out here. Well, that's pretty interesting. Why would that cluster be out there and so small? Well, you could consider this cluster of a few points out here an anomaly, depending on how big these were and how big that was, of course. So anomalies are pretty interesting because it's probably something that we would be real interested in our data set. Why are these customers so much different from any other customer? Or let's flip into computer security. Let's say these are transactions in a firewall log. Why are these so much different than every other transaction? Could these be hackers? Could these be someone doing something bad? Maybe, and it's definitely worth some interrogation. That's just a little bit of clustering. We're going to do some clustering in the class, and that's going to come later. But for now, it's good enough to just kind of understand what clustering is. The last model I'm going to talk about is a recommender. And this is a very easy one for me to talk about. Why is it so easy? Because almost everyone in the class has probably used one of these recommenders. Two good examples of recommenders would be the Netflix system and maybe Amazon. If you've ever shopped online on Amazon, you've experienced their recommender. What the recommender does is it says, based on what you like, based on you, how about let's say based on items you like, we're going to use all of the other people that have ever purchased things from Amazon, or whoever the recommender is for, and we're going to recommend things for you recommend items for you based on the likes of other people who are like you. So, said really simply, all that means is if I happen to like science fiction and math books, and you happen to like science fiction and math books, and I haven't read a book that you have, there's a good chance that I might like that book. And so what Amazon can do, or the recommender system, is it can recommend that book to me as one that I would like to find or to read. Does that sound a lot like search in a way? Yeah, it is kind of like search. The difference between search and a recommender is that recommenders are good at helping you find things that you wouldn't have searched for. Okay, so just another real quick recap today. Machine learning can be broken down into two main categories: supervised and unsupervised. All right, remember the difference? The difference is supervised has labeled data, unsupervised has unlabeled data. And then inside of supervised, there are regression algorithms and classification. And inside of unsupervised, you have clustering, recommenders, and then there's some others that I haven't talked about. In supervised, even if I haven't talked about them, they probably fit into these two categories. In unsupervised, there's some other things that fall outside of these categories as well. And if you're interested in that, we can certainly have more discussions on that, and you can check out the documentation for like scikit-learn. You'll find a variety of algorithms that are out there. All right, so that is my very brief introduction to machine learning. Next up, we're going to talk about how do you know if your model is good?